Hello, my name is Jacob Tucker. I'd like to start this out with just a little bit of humor. So Jesus and Satan have an argument as to who is the better programmer. This goes on for hours until they come to an agreement to hold a contest with God as the judge. They set themselves before the computers and begin. They type furiously, lines of code streaming up the stream, for several hours straight. Seconds before the end of the competition, a bolt of lightning strikes, taking out the electricity. Moments later, the power is restored, and God announces that the contest is over. He asks Satan to show his work. Visibly upset, Satan cries and says, "I have nothing. I've lost it all when the power went out." "Very well," says God. "Let us see if Jesus has fared any better." Jesus presses a key and the screen comes to life in vivid display. The voices of an angelic choir pour forth from the speakers. Satan is astonished. He stutters, "But how? I lost everything, yet Jesus' program is intact. How did he do this?" God just chuckles and says, "Everybody knows. Jesus saves." So that's pretty much who I am. I enjoy the mental exercise of programming, and really all that school is, and kind of consider myself one of the better students in the school. But also, I constantly seek to strive to be stronger in my faith with Jesus and just kind of grow more like him every day. So those are kind of the two halves of me. Going back to the programming part, I'm from Eureka High School and have taken a few programming courses from there. Some of the languages I've worked with are Java, Visual Basic, and Python. Now I'm best at Java, taking it for a little over a year now. And it's just a very logical language, as all programming is, but it's fine that it works very well. So kind of like the process I take when doing a program, the way the course is structured is we are just given assignments, problems such as make something to monitor a parking garage and keep track of where all the cars are parked, unpark them, park them, and just all that kind of stuff. And then we're just let loose to accomplish that task however we see fit. It's a little collaborative, so we'll bounce ideas off of one another, but in the end it's just you and your computer and working towards a solution. So you get that problem and then you have a few ideas of how to solve it. Usually you'll kind of get a basic idea, put it on paper, see any possible problems, what you actually have to get it accomplished, and then go ahead and start coding it, debugging, and then whenever it actually works, refining that and making it more efficient. So one of the most difficult programs I've ever done was the word ladder. I believe I've sent that with my resume on the first phase of this. And I'm just going to go over kind of like the basic idea I used behind that and a little bit of my problem solving and that. So the task was to get from one word to an end word by just changing one letter at a time, and try to do that the fastest and most efficient way possible. So the first way I started was a scoring system. The general concept is on this piece of paper. As you can see, you have the start word, and from the start word you have all possible words that are just one letter off of the same length. Once I had all those out in the list, I just went and I scored them based on how many letters are similar to the end word. So you can see we have some zeros, some ones, and a 2. So that means that the first word actually shared one letter with the end word. So after that, you just follow the word with the highest score in that, and then do the same thing in the next step. So in this case, we ended up getting a score of 3, which is the highest, and then continue that, and in that list there's a word with a score of 4, and since the end word has a length of 4, that would be the end word, and then you can just trace that back up. So a practical example is going from cat to dog. You can see here we have all sorts of words that are just one letter off a cat. This is by no means all of the words that are just one letter off a cat, but just a few. You can see most of these have 0 letters in common in the same place with the word dog, but however, caught does have one. So then we trace that down to the next step. So then we have all sorts of things, not, lot, dot, cog, cow, and cob are these examples. And then most of them only share one letter, the letter O with dog, but however dot and cog will share two letters with dog. So it would randomly select one of these. In this case, we went with cog and continued. So then we have bog, dog, fog, nog, and sog. Dog has a score of 3 and matches the N word. So then we know dog. So we have that. So the word letter is complete, and just trace that back up through the parents. So like this way was very short on memory. You only had to do one stem for each step instead of going off of each individual word. So it was very efficient in that. However, it would often just kind of clog up the error out whenever a list would be too big, or sometimes it would just be stuck and couldn't quite figure out where to go. So that was the main problem with that way. And then, so because it kept getting stuck and wouldn't finish and only did kind of simple 3 or 4 letter words, I kind of went with a more complicated system. So I called it the node board system. So it uses 2 different main classes, one class called step ladder to do all the calculation and the basic like actual program, and then the driver program. So also with the node and board classes to make objects from that. So with the node we have content, which is just going to be the string of the word that node is, as well as the board it belongs to. In this case it's called parent board. The board, it has a list of nodes inside of it that the board contains, as well as a parent node that it stems from. So the general concept is you would have a list of nodes in here. So this would be the very first board, and from each node in that board stems off another board with a list of nodes in it. So in this case we only drew out very simply that there's 3 from this, and then as you can see each different node stems to a board. Then you'll eventually get to a board that contains the node with a content that is the same as the N word, and then you can just trace up the parents. So again, back to that cat and dog example. So we start with cat, so that only has 1 word in it, so it stems 1 board. Just 2 examples that are 1 letter off of that would be cot and car. So those are the 2 different nodes in that board. There would be much more in the actual program, but due to space it's limited. And then, so we trace each one down. So cot, so we have stuff that's just 1 letter off of cot that hasn't been used already because there's a used word array list also in the program, so you don't just kind of clog it up and go in circles. So from that, we have a board that comes off a lot, a board that comes off a cow, and a board that comes off a cog. In the board that comes off a cog, we have things such as log and dog. Dog, of course, is the N word, so then you know you're done, and then you just trace back up to the parents again. So what was cool about that way was just that it always gets the shortest path possible. It does take a little bit more memory, but it also doesn't get stuck unless it's just a really long word ladder and there's too many spots for the computer to handle. So that was kind of my crowning achievement in programming so far, and the little that I've done. Just kind of finding a system, seeing the flaws in it, and then reforming it to a better way of doing it. So, like general qualities of my program, overall, I usually finish towards the beginning of my classes. I'm usually done with all the assignments fairly early in the semester. And just with that, I try to keep it all as neat as possible, line up all French braces, and just kind of take shortcuts when the API lets me in that kind of way. I try to keep it also pretty simple, so whenever I do it over multiple days I can understand what I did, give comments in that, and just kind of make sure that the logic is there, and then all I have to do is fix a few little syntax errors. So as I said, the class is run in a collaborative environment, and so with that we're often helping one another in it. Some you are actually forced to work with a partner, so it's just communicating the 2 different ways of logic in that to make one program that runs and you kind of balance each other out. So whenever you didn't think of something, hopefully the other person thinks of something to solve that, and just kind of cover all the bases on that. So it's very important to also compromise with that and not just be like stuck on your way, but also listen to the ideas of others. So also I am the leader of the robotics team. Before that I was the head programmer of that. So the two main phases of a robotics competition are the autonomous, where the robot drives itself, and then the teleop, wherever the drivers actually have the controls. So with the teleop, with the autonomous, it's all about precision as well as speed. There's 4 robots on the course at one time, so you have to make sure that it goes exactly where you thought it would go, and that usually uses sensors as well as encoders and all kinds of stuff like that, and just a lot of testing to make sure it does the same thing every time, as well as doing that quickly so that it does not get impeded by other robots. Whenever you go to the teleop mode, simplicity is huge. You need to be able to have the drivers just do a few things to get it to do what it wants rather than a whole bunch of commands, because time is very precious in that. And with that, reducing the lag times, the times it takes processing the commands is also very vital. So just kind of making it as efficient as possible. So those have been some interesting challenges I've had while programming for robotics. And as I said in the resume, it's FTC Team 3658. Also, I'm very skilled in mathematics, which is very closely related to programming, and a strong basis in math really kind of helps with that. And just kind of helping others is kind of one of the big things for me. It's like people will come to me for math help. They'll ask me to help solve bugs in their programs, and us with that collaborative environment I've been talking about, just kind of working with people to get the best product possible. So that's most of what I am. I mean, there's a lot more, but in time constraints, that is most of the main points. So I want to thank you for giving me this opportunity. I'm really interested in pursuing software development and engineering in the future. I plan to go to the college for that. And I just think this opportunity is awesome because it gives me some hands-on experience and kind of see what the industry actually is all about, and just learn with some really great professionals as well as fellow interns, and just hopefully learn a lot through that, grow in skills, as well as kind of give back to Oasis Digital and just kind of make their days a little better. So once again, I'm Jacob Tucker from your high school, and thank you for presenting this opportunity.